All right, next question up. What we see here is, well, how much volume remains empty? So the full question sentence reads, after loading cargo that takes up this much space, how much volume remains empty? So one thing we need to understand is to understand how much volume remains empty, after we loaded something, that's going to be subtraction. That's going to be subtraction. What we're trying to do here is, look, let me actually just read the entire story so you can, get the whole picture. We got a truck trailer that has these dimensions. It has a length, a width, and a height. So again, if we're taking a look at this truck trailer, we can go ahead and draw it like this if we'd like to. Something to this effect. So I can just draw out this little trailer, yada, yada, yada. And then from there, connect all the dots. Perfect. So we have this truck trailer. We can pretend that, the truck is actually over here. Here's the container. And we have these dimensions. We have a length, a width, and a height. And then we're saying, hey, look, after we're loading cargo that takes up, let's go ahead and say, this much space over here. Well, how much is left? And this is a subtraction problem all the way. If we fill in this part of the tank and we want to know how much is left, that is subtraction. We will subtract the volume of the trailer. We will subtract it by the volume of the load, of the cargo. So volume of the cargo. So once we find the individual volumes, we can subtract and we're done. That's it. It doesn't have to be any more complicated than that. So let's get to work. Let's move that out of the way, even though I missed the last little line there, no problem. Let's find these volumes. I already have the volume of my cargo right over here. So I'll just go ahead and put 960 cubic feet there. For the trailer, that's a rectangular prism. So that'll end up being length times width times height. My length is going to be 20 feet. My width is going to be 8 feet. And my height is 9 feet. So again, all listed in feet, so we're good. So we'll have 20 multiplied by 8 times 9. So 20 times 8 is 160. 160 times 9, let's see what that'll be. So that'll end up being 0. 6 times 9 gives us 54, carry the 5. And then 1 times 9 is 9. Carry the 5 is 14. All right, so we end up getting 1,440 cubic feet. So again, let's write that here, 1,440 cubic feet. So we're not done. That's not the correct answer because we have to subtract. That was the last thing we had to do. And so now we have 1,440 minus 960. That will give us the proper correct answer. And so let's just go ahead and write that down and do it over here. 1,440, 960, subtract. That's a 0. Then we'll borrow right there. 14 minus 6 gives us 8. Then 13 minus 9 gives us 4. And that is the difference in the volume, everybody. That is the answer, 480 cubic feet, which makes it answer choice C. And there we go, everybody. Again, this was a problem where, volume was involved, but it wasn't the only thing we had to do. We had to subtract, and that's how we got it. So here's another one. Let's begin with the question sentence. And that question sentence, as always, is the first priority. So how many quarts is this? Okay, sounds good. So another straightforward unit conversion problem where they say, hey, here's this container's capacity, 3.2 gallons of liquid, but we really need to know how many quarts that's going to be. Okay, sounds good. So we have 3.2 gallons to begin with. And we want to turn that into an unknown number of quarts. So with that, let's write that conversion first. Let's write that conversion first so we can understand whether we're going to multiply or divide. And I don't want us to just rely on the answer choices to see what that might be. Let's really use reasoning. Let's pretend the answer choices aren't even there. So what we need to know is that 1 gallon equals 4 quarts. 4 quarts makes 1 gallon. So my party people, we are trying to get 2 quarts. We're trying to get 2 quarts. So because we're trying to get to the unit that has the number on it, we will perform what operation? Because we're trying to get to that unit with the number on it, yeah, we're going to multiply. If we were trying to get to gallons, that's a 1 on it, and we would be dividing in that case. But in this case, we'll multiply. So that means we'll do 3.2 multiplied by 4, again, by that number that we have right there, our conversion rate, nice and easy. And so 3.2 multiplied by 4, 2 times 4 is going to be 8. 3 times 4 is going to be 12. And then from here, we're done with the exception of really just making sure we're following those decimal rules. So we have 1 decimal place up top, none on the bottom. So it's still going to be 1 that we'll bring back. And there we go. 3.2 gallons is going to be the equivalent of 12.8 quarts. And that's going to make the correct answer here. Answer choice D. All right, so let's go ahead and take a look at this problem here where the first thing we always want to do is we want to read that question sentence. And it says, how many cups of sugar were used in total? So again, let's highlight that there. How many cups of sugar used in total? Now, go ahead and answer this for me. As you sit and think about it, when we think about the phrase in total, what operation typically pops up in your head when you think about that? Yeah, and if you're saying addition, yeah, you're absolutely right. The majority of the situations that include in total, typically you have to add everything up, or at least find, everything all together. And that's typically going to be addition, sometimes multiplication. But in this case, when we take a look, it says the lemonade stand used this much sugar in the morning and this much sugar in the afternoon. So it really looks like, to find the total amount of sugar, take this and that and add it all together. And that's what I'll do. I'll have 3/8 and I'll add that with 1/4. And that's how we're going to achieve the answer, just adding this up. Now, the only little detail that we have to address is that when it comes to adding fractions, we have to have the same denominator. In this case, we do not. So here's what we need to think about. The biggest thing about manipulating fractions is whatever you do to the numerator, do to the denominator. That's it. That's pretty much the idea behind simplification, behind like denominators, behind a lot of these ideas with fractions, is just making sure you keep that balance. So with that said, everybody, when we want a like denominator between 8 and 4, first, we always want to ask, can the smaller number go into the bigger number? Because if it can, then it's going to be a lot easier than typical. And let's ask that question here, everybody. Can 4 go into 8? Yeah, the answer is going to be yes, absolutely. What do I multiply 4 by to get to 8, my party people? Yeah, that's going to be 2. Absolutely. So let's just go ahead here and modify this fraction, just this one, by multiplying the numerator and denominator by 2. So there we are. 1 multiplied by 2 in the numerator is 2. 4 multiplied by 2 in the denominator is 8. So we have 3/8 plus 2/8. And now we're good. So as a nice reminder for those of us out there with this refresher problem here, when we add or subtract fractions, we're going to keep the denominator the same. It's kind of like talking about pizza. So this pizza box can hold 8 slices, but there are 3 in there. So 3 out of 8 slices of pizza plus 2 out of 8 slices of pizza, well, that's going to give us 5 out of 8 slices. So boom, there that is. In this problem, we really had to refresh on, well, getting the same denominator when it came to adding fractions, and then just reminding ourselves of the rules and taking care of that therein. But there we are, my party people. The correct answer here is C, 5/8, and I hope you're ready for another one.